or coffee inside the insulated flask, and if it will remain same temperature, the temperature at the time of pouring, if the same temperature will remain for infinite amount of times, then we can say that the system is an isolated system. But from practical phenomena we know that this is not possible. So only one best example of isolated system is possible in whole universe is universe itself. So isolated system is only our universe. Okay, now let us see concept of continuum. What is continuum? And we are going to look the concept of this. Okay, so in case of the continuum, in our system, how we are going to select the region or a matter. We have to select the region like that, in a small region, but we can get a tremendous amount of molecules and of similar manner. So we have to study that particular molecule, but that molecule study will helpful for us to study the every molecule in that region. So we can say that suppose the graph is like that, the domain of continuum side and a domain of molecular effect. So we have to move towards the domain of continuum side, because as you go towards the continuum side, you will get a small region. In that region there are lots of molecules, while in case of a domain of molecular effect sites, you will get the large area, large matter, but it has a less molecules. And more benefit on domain of continuum side is that it is continuous, means all the molecules have a similar approach. So we should have to select a region where domain of molecular effect is negligible. So this is the concept of continuum, in which it gives the criteria for applying macroscopic point of view, so that averaging should be meaningful and matter is considered as a continuous. Yeah, averaging should be meaningful and matter is considered as a continuous. So for that approach only, the concept of continuum is taken in focus. And here the attention is focused on small volume, which is a very large compared to molecular dimensions. Even very small volume contains a very large number of molecules, right? So we have to select a small volume which is contain a very large number of molecules, and by studying that molecules in a meaningful way, we can consider it as a continuous study. And after that, the next important topic is thermodynamics property. By property we can identify the system. It is a characteristics of the system. Remember, the properties are the characteristics of the system, and there are the main two properties which are really very important in case of the thermodynamics, that are intensive properties and extensive properties. Intensive properties. Intensive, independent of mass or size of the system, it is said to be as a intensive property, and examples are pressure, temperature, velocity, viscosity, density. Whereas in case of extensive property, which is totally dependent on mass or size of the system, and examples are mass, volume, magnetic field, electrical field, etc. By name you can get some idea that yeah, it is independent of mass. Yeah, it is a dependent on mass. For example, volume, it is all about the mass. Pressure, it doesn't depend on mass. Whatever the big size, the pressure should be the same. Temperature, it should be the same. Velocity, it should be the same. The vehicle is moving on the same velocity. Viscosity, density is an exception. We will see this how it is intensive property. It is kg per meter cube. We know that kg mass extensive property, meter cube is a volume, so it is a ratio of two extensive property. Then how it is in the intensive property, we will see this, because there are 5 notes we have to remember for property, which will really very helpful for us to identify the property, and that notes are this. Remember one thing is that ratio of two extensive properties always intensive property. For example, density, its unit is kg per meter cube. Kg is mass, meter cube is volume, and together we can say that it is an intensive property. And second thing is specific properties are always intensive. Specific volume, any specific thing are the intensive always. So volume is a extensive property, but specific volume is an intensive property because it is a specific, right? And specific properties are always represented by small letters because these are the specific. Volume we can describe by a capital V. So there should be something different notation for specific volume. So it is small v. Properties are independent of past history. It does not depend on past history. Properties are state function or a point function. It could, it is a state function, point function. It cannot be a path function. And properties are exact differential. As it is not a path function, it is an exact differential. If it is a path function, it must be inexact differential. Further, next topic is state of the system. When all the properties of the system has fixed and defined value, the system is said to exist in a state. State is represent the condition of the system, and properties are the coordinates to describe the state. State is just one point, that is a property. One point on a graph, that is a property, and it will describe the state. The properties are describing the state. We will see this and everything will be clear in the graphs we will gonna study later. So keep this in mind. The properties are the coordinates to describe the state. Okay, further there is a Gibbs phase rule. Okay, we can study this after knowing what is independent and dependent properties. So let us consider M. M is the total number of properties of the system in which n are independent. Suppose there are m properties of any particular system, in that n are independent. It means if we fixed n independent properties, then remaining m minus n properties will be automatically fixed. This is proved by Gibbs phase rule. And to determine the minimum number of independent properties to identify the system, Gibbs phase rule is used to identify the system. From this we can understand better. Gibbs gives this equation that P plus F is equal to C plus 2. P means number of phases, F means degree of freedom, C means number of components plus 2. And degree of freedom means it is the minimum number of independent properties to fix the state of the system. So we are going to find out the degree of freedom for every particular system, so that we can say that what are the minimum number of